We are live. So in this video, I'm going to talk about the for loop. And this is another bit of tool that you can use to kind of repeat a block of code multiple times. And it typically operates on a list. That's why I'm covering it after the list. So let me just give you a quick example. It's probably the best way to show this. I can say x is equal to 1, 2, 3, 4, 5, 6. And then I can say for some element in x, let's print that element. And I'm going to get back the list, right? So for each element, it's going to print 1, so the first time, and then the next time it goes through the loop, it's going to print 2, 3, 4, 5, 6. Now I can do multiple things, so I can also print, maybe element, times 2 if it's a number, and then it's printing the second element, so 1 times 2 is 2, 2 times 2 is 4, 3 times 3 is 6. So we can put as much code here. This is actually really messy. I should probably come back here. And I could do maybe like element. I think we did this with a while loop. Element squared. And then I have going through the elements and the elements squared. One thing, let me just take out the squared part, is that we can also operate on lists of all different kinds of things. So I could put in some text. I can put in another list, so 5, 6, 7. And then if I print it, again, it's still going to go through the different elements. So for the element in x, it's printing the first element, the second element, the third element, the fourth element, the fifth element, and the sixth element, and it knows how to operate on that. One other useful thing, sometimes with going through lists, and let me just grab this, is sometimes you also want to know the index associated with the element. So we could do for I comma element in enumerate x. And what this is going to do is I can print the I and then the element. And what I'm going to get here is the I is going to tell me the index. So 0, 1, 2, 3, 4, 5, 6. And the element is going to tell me the associated element in the list. Sometimes this bit of code is useful. So a common thing you want to do in writing code is sometimes you want to do a for loop and you don't actually have a list ahead of time, and maybe you want to repeat a block of code X number of times. And here we can use the range command. So we could say for I and say range of 6, right? What we can do is print I, and what that's going to do is take, basically range is going to create a list of ordered integers, so starting 0, 1, 2, 3, 4, 5. It's going to have 6 elements in it, right? Or the other way you can think about it, it's going to start at 0 and go up to, but not including the last element, 6, and then it's going to print the different values of I. Now, just kind of like what we were doing with slices in lists, we can maybe start at the value 2. Let's go to 2 to 10. And here we're going to start at 2, and then we're going to go all the way up to, but not including 10. And we can also maybe stride by a value of 2. So we can go 2, 4, 6, 8, but not including 10 because, again, the range is 9. And then we can do all kinds of different things. Maybe we want to look at I squared, and so on. And then we're going to have all our different code. So you can have a lot of things in the for loop, but it's very useful. We're actually going to use it a lot to do different kinds of calculations. So kind of give you an example. Maybe we're going to say, it's probably not the best looking code, but let's say kind of on our list, I say maybe we say y is an empty set. And so we're going to say for I in range of 20, let's do 10 so you can visualize it. What we can do here is maybe we can set, some variable x is maybe I squared plus 2 times I, like a polynomial, plus 1. And then we could say y append that x value, and then over here we can print that y value. And so for the first time, it's going to calculate the x value for I equals 1, which is the 1 value, right? The 0 value, right? Because 0 plus 0 and 1. Then 1 squared plus 2 plus 1 is 4. And we're going on and we're generating the numbers. The other way to do this code is probably a little bit better. If we know we're going to do 10, so maybe we're going to say the number of elements, let's say n is equal to 20. We could set y is equal to like 0 or n times 0. So this is going to pre-allocate our array. And then we can say for I in, again, range 10, we can still have our x value up here. So let me just copy and paste this. And then we could say y of I is equal to x. And then print, the y command, right? What did I do wrong? Oh, I did it. I see, messed up. I got the n's wrong. I forgot to put n there. So let's just put n and make it 10. And we get back exactly the same code. This one will run a little bit faster because we're pre-allocating the y list, whereas here we're actually having to reconstruct. Every time we run this append command, we're taking the old list, destroying it, and then making a new list that contains one extra element. Here we're kind of pre-allocating it, so this is a little bit cheaper, and we're just simply accessing the different elements and setting the different values. So I think I'll just stop there. You're going to see a lot of examples of lists. They're really useful, or you'll see a lot of examples of using for loops operating on lists. Later we'll show how we can do for loops also on arrays. And arrays are just lists that are focused on numbers that we can do math on, and that's when we come into NumPy. And so with that, I will stop there. And again, if you have questions, please post them to the comment section or put them on Piazza, or even then you can always send me an email. All right, thank you.